Thanks for coming. I hope you enjoy this session. Make sure your tray tables are in the upright and locked position. We'll get going in just a moment. So this is the Pass the Hash, another credential theft and reuse presentation. My name is Aaron Margosis. I'm on the Microsoft cybersecurity team. I'm based out of the Washington, D.C. area. I do a lot of stuff with Windows internals and have been for a long time, focusing on security, non-admin, the sysinternals utilities. For those of you interested in the sysinternals utilities, I've got a session later on today at 5 o'clock, sort of a preview of the second edition of the sysinternals book. But this one is all about Pass the Hash and credential theft. Now, Pass the Hash is one form of credential theft. The kind of credential theft we're talking about are the things that you provide to the computer to prove who you are, right? Your credentials. Pass the Hash is just one type of that. And it's getting a lot of attention, relatively speaking, compared to other kinds of credential theft. And I think there's a couple of reasons. One is it's being fairly widely used to take over victims' networks. And the other is, I think, because it has a cool name. You know, Pass the Hash. That sounds really cool. Now, I don't know how old most of you are. I think there's some of you who will remember. Back when I was growing up, Pass the Hash was not a problem. In fact, if you had some and you didn't pass it, then you were considered rather a jerk and a selfish one. I wondered, actually, when I saw the crowd, if many of you were expecting some to be passed around. But times change, and that is not what we're talking about here. What we're talking about is a cryptographic byproduct called a hash. And so, yeah, this is something now we absolutely want to stop. So for those of you who are disappointed in that, I'm terribly sorry, but it's not about that. So we're going to describe the problem. We're going to go through a typical attack scenario. We'll go through a demo so you can see exactly what's going on. And then we'll talk about some mitigation, some things that you can do without involving expensive consultants, stuff you can do on your own to help reduce the likelihood of your becoming a victim. And then we'll talk about some next steps. So Microsoft is paying a lot of attention now to the Pass the Hash problem. I think it may have been underestimated for a while, but some things changed. You know, the Pass the Hash attack itself is a rather complex one and difficult one to execute until somebody comes along and builds a tool that does it for you very quickly and very easily. So now it's just a simple command line attack. You get that thing running on a box, and then you can spread throughout a network very quickly. So we have a lot of people, including some very high-level people, taking a look at this and trying to come up with things to reduce the likelihood of people becoming victims of this. Mark Rusinovich is in here. Mark Simos is on the cyber team with me. He co-presented with me back in the US. And he's going to be the main point of contact for follow-ups. So the nature of the problem, as you know, the internet is a great, wonderful place that interconnects us to all kinds of things that we want to be connected to. At the same time, there's some actors out there who are taking advantage of that as well. And some of them are very clever, very well funded, and have some really smart people trying to figure out how to take control of other people's computers. And it may be just, you know, ordinary individuals, and you want their credit card numbers and their banking logon and stuff like that, and you want to gain access to their hard drives and so forth. But businesses are now being targeted and specifically targeted for the value of what a business owns and the business's IP, what the proposals are that they're going to make so that they can be undercut by a competitor. And so we're seeing a lot of these kinds this kind of criminal activity with increasing levels of sophistication all the time. One example that we have here is the Brazilian rainforest is now a victim of cybercrime. Okay, so people who wanted to be able to chop down more trees in the rainforest hacked into the Brazilian government's systems to try to gain control of those and change the numbers and give them more access than they were actually entitled to. And some of these attacks, instead of using exploits to take over a system, now actually use your systems against you. Okay, so they may use your patching system to attack you. And in fact, pass the hash is exactly that. It is a mechanism by which it uses the operating system's native functionality to do single sign-on from one computer to the next and take over an entire environment. In the example here, which I believe was pass the hash was a significant part of it, is Saudi Aramco, the big oil company in Saudi Arabia. The attackers actually did something a little different. Most of the time, attackers want to come in and act very stealthily, not be noticed, and then extract information, gain control of the environment, and then extract all the information out. In this case, the attackers went in to burn the network down. And they went in, took control of the entire environment, and then managed to make 3/4 of their computers unbootable, replacing all data files with a GIF image of a burning American flag. So the attack scenario, there's two different parts to this. One is lateral escalation, or lateral movement rather, where once you gain control of one computer, then you use that as a jumping off point to gain control of computers of similar value. Okay? And then there's privilege escalation, where you find the ability to access computers of higher value, such as SQL servers or domain controllers. So here's a typical pass the hash attack. A bad guy targets a bunch of workstations and sends them a specially crafted email, for example. This is typical as an email. It may contain a malformed PDF or Excel spreadsheet that triggers a vulnerability in Excel or Adobe Reader, or it may not. Or it may cause them to click on a link and go out to a website where attack code is hosted. In any case, all they need is for one of those machines to fall victim. Okay? Now, for the credential theft we're talking about, Windows account credentials, you need to gain admin control of the computer. Okay, so we're not talking about your Amazon password or your Amazon Web Services password or credit card numbers or anything like that. We're talking specifically about the credentials that the operating system manages to log on to Windows systems, either local accounts or domain accounts. You need admin control, but there are lots of ways to get that. Once they do, they use that power to gain control of other computers in a lateral movement. So take over the next one, perhaps using the local admin account. You grab the credentials of the local admin, and in a lot of environments, the admin account, all the local accounts have the same username and password on every single machine. So if you can harvest that information, you can use that to take control of other computers in the environment. How many of you have the same username and password on local administrative accounts in your environment? It's the typical way they get deployed. No? Only a few. Okay, very good. Eventually, though, the attacker gains control of a workstation that has credentials of a higher privilege level. So a domain admin had logged on to this machine. That's the golden ticket. From here, they can steal those credentials, take control of the domain controller, and they own everything. So that's the typical pass the hash. So let's demo some of this. Okay, so I am logged on to this workstation. I'm logged on using a local account. Okay, so it's not going to be recognized on other workstations in the environment or the domain controller. Let me demonstrate some tools first that I'm going to be using here. So one of them is a sysinternals utility called logon sessions. And what this shows you are all the LSA sessions, the Local Security Authority subsystem, LSAS, maintains all the information about who is logged onto the computer and how they're logged on. So, for example, I have this Abby account that I'm using. It's a local account, and it's logged on interactively in session 1. There's also logon sessions for the computer account, running as local system, running as network service, running as local service. And the logon types are different for each of these. So the different types of logons, you may have interactive logon, remote interactive if it's remote desktop, network logon if it's a net use type of logon. And let me show you a script I'm going to be running here. Just to reduce the amount of information, I only want to show the username and the logon type. And so I'm just going to run this script to do that. And you see it'll just show you the username and the logon type, because I'm going to be coming back to this again and again. So that's logon sessions. That's a sysinternals utility. And I want to point out that it uses documented and supported APIs to enumerate that information. So you can write a tool that does the same thing using Visual Studio. By contrast, there's a tool called WCE, the Windows Credential Editor. And what it does is it uses undocumented entry points and reverse engineered information about data structures inside LSAS to pull out information that is not supposed to be exposed. Okay? And this includes, for each logged on user, the hash. If it finds a hash in memory, it's going to show it on the screen. So what is the hash? This is the landman hash here, and this is the NTLM hash here. So a hash is basically, it's the output of a cryptographic algorithm, right? How many of you know what hashes are? Most of you? Okay, let me just go through it really, really quickly. So it's a cryptographic algorithm. You put in any arbitrary amount of data, and you get out a fixed amount of binary data called the hash. A couple aspects of it: if you change one bit of the input data, the output is completely different, completely unrelated to the original hash. Second, it's repeatable. So you put in the same data, you'll get the same hash every time. And third, it's a one-way function. So there's no unhash. There's no way to take a hash value and reverse the algorithm to find what the original data was. So for some types of authentication, like using NTLM, it actually uses the hash of the password to authenticate over the wire to another computer. And so LSAS maintains that information in memory so that when you want to authenticate to another computer, single sign-on, it uses that hash that it has in memory and authenticates to that remote machine. So why is WCE able to do this? Because it's running as admin. I'm logged on here in a command shell prompt running as local administrator. Local administrator and the operating system, there's no security boundary between them. There's no way to stop anything running with admin rights from doing anything to the operating system. Any data that's visible to the operating system is visible to any admin on the machine. And so what they've done is they've reverse engineered some aspects of Windows and figured out where the secrets are. So what can I do with this? So I'm running with a local account. If I try to do a directory listing of the $C directory of the domain controller, I'm going to get logon failure, unknown username, or bad password. Okay? It's not going to recognize this local account. So what I'm going to do is I'm going to run WCE. And what I'm going to do here is I'm going to run it in the background. Okay? Not logged on. So the way I'm going to do that is I'm going to run psexec, another sysinternals utility. psexec-s says run this thing as local system in session 0 in a non-interactive desktop so that it survives logoff. Okay, it's not running in this user session. It's running in the same context where system services run. -d says don't wait for the command to return before exiting psexec. And here's the command I'm going to run. WCE -E says continue to run and wait for logon events. And whenever you see a logon event, dump the information, dump the additional hashes that you find. -O says write it to this file. Okay, let me run Process Explorer here really quickly. And I'm going to run psexec. We now have WCE running as system in session 0. Now I'm going to log off completely. Okay, no one's logged on. Domain admin comes along and logs on. System is now owned. You don't see it, you don't feel it, but the domain controller, if I were running the right software, would now be completely under the control of the attacker. Let me show you how. I'm going to log off. Completely log off, so there is nothing in memory representing the domain admin anymore. And I'm going to go back into the local account to show you what's different. Did you know you could do this? / says local account. Oh, the administrator still has an interactive logon. That's going to disappear in just a second. Sometimes it takes a little while for that to flush out completely. Oh, come on. Don't make me a liar. There, okay, it's gone. It is no longer in memory. Okay, you can see here I've got these Abby LSA sessions. Appears one of them leaked for some reason. But it's all just this local account, and the domain admin is not in memory. And if I do WCE to look at the hashes that are in memory, I still have the Abby hash, which is the account I'm running as, so that's no surprise, and the machine account. I'm already running as admin on the local machine, so that doesn't give me anything additional. However, it wrote this file that I told it to write. And here are the hashes for the domain admin. So let me show you one more time really quickly that I'm still running as the local account. I don't have any access to the domain controller. And I'm going to copy the hash. And I'm going to use WCE with -S to say, take this hash and stuff it into my current context. So go into LSASS and patch the memory that represents the hash I'm using now and use this instead. So now I'm using the domain admin's hash. And now, if I do a directory listing, I'm in. Let me go over to the domain controller and see what that looks like. Should see, there should be a logon here for the, oh, there it was. Yes, here is a logon. This is PS log list, another sysinternals tool. It's a command line utility that lets you dump events out of the various event logs. And here is a logon from the domain administrator, logon type 3, which is a network logon. So it thinks that the domain admin logging in from this workstation has done a network logon. It cannot tell the difference between that and a hack. Okay, and from here I can do all kinds of other things because I've got control of that domain controller, and I can now go in and create new directories and fill it with anything I need. I am now the domain admin. So how's that look? Now all it's doing is using the operating system's functionality against it. That's all it's doing. There's not a vulnerability here, or there's not a bug in Windows. This is just the nature of operating systems that have a super user account, whether it's administrator or root or whatever. You have an account that has absolute control of the operating system. It can be misused to abuse that operating system. So one last thing I want to show you here in this demo. An additional thing that I believe Mimikatz does and WCE does is it can also go through memory and reverse the passwords that it finds, because in order to support digest authentication, the operating system has your plain text password encrypted in memory, and of course, because the operating system needs to have the ability to decrypt it in order to use it to perform digest authentication, an attacker can also, if the attacker knows the encryption algorithm and the decryption algorithm and where the decryption keys are stored, which they have to be on the system, they exercise that and they can reverse the passwords that are in memory. And you can see here that, of course, I always use the strongest passwords with upper and lower case and symbols and digits. So strong passwords are really good. No laugh at all for that one. Okay. Irony, not an actual strong password. Don't use this at home. Okay, so that's the demo. Any questions? If there's any questions, please feel free, because there's a lot of topics here that may be, I may be misstating it or not stating it clearly enough. So please, if you want to ask a question, we need a microphone. I was going to have someone with a microphone. You're going to have to run a lot today. Faster. Over here. Over here. Oh, thank you. Didn't see you.
Thanks. In the US session, you made a point of saying that you don't need this VCE tool to do this, because anyone who has the code to do these things, they can do the attack, just make their own custom code to do it. That was an important point I think you made in the US session of this. So you don't need that tool to do this attack.
Right.
That's the
no.
point.
Yeah. So WCE is a tool that someone wrote. Anybody can write the same tool, or a similar tool, or a better tool, right? But you know, one thing to note, first of all, if you heard the US session, you heard me mention that this is not a Microsoft tool. This is not a Microsoft utility. We don't write utilities like this. This is a hacker tool, or a security researcher tool, which is the polite way of saying evil guy. Right, Marcus? Yeah. Got Marcus Murray here, so very nice evil guy. And Hassan too. And the other thing you can note here is you can tell it's not a Microsoft tool, because when you run it, it never asks you to approve an end-user license agreement. But yeah, it's just, you know, they've gone in, they've figured out where things are, and they've made it easy for anybody to exercise that same functionality. And there's other tools that do the same type of thing. This is just one of the better known ones. Any other questions? Question over here.
Yes. If that domain admin had logged on using a smart card, would that could you still steal the hash?
If the domain admin has logged on using a smart card, yes. If NTLM is involved at all in there, the account has a hash associated with it. If the smart card account allows password or smart card, then it's going to be a hash of the password. If it's smart card required for interactive logon, that bit is set, then it generates a random value for the hash. But there's still a hash associated with the count. It's still going to be in memory. Okay. Another thing to note is that if you get rid of the hashes completely, the thing is you're still entering passwords. You're still getting a user token representing this user who can authenticate to remote machines. And so you can steal Kerberos tickets. You can steal passwords. You can just grab a token out of a process that's running as domain admin, duplicate it into another process, and then start doing things as the domain admin. Or inject code into that process. There's lots of ways to repurpose something if it's on the system.
Okay, but if the hash is there and it's generated with logged on with a smart card, and the bit is set for this user to require smart card to log on, can you reuse that information to log on like you did without having a smart card? So.
Yeah, the hash is still going to be, you can take that hash and use it from any place. Okay. Now there is a technology that we're starting to look at, authentication mechanism assurance, that allows you to use smart card and set up the PKI so that you need to have an interactive logon in order to get the ticket, you know, the Kerberos ticket going. But even then, if the attacker owns the system on which that user logs on, the attacker can become domain admin, at least as long as the ticket is good. Okay, but in that amount of time, they can do other things that give them permanent presence. So if I were the attacker and I had control of a machine that you logged on with one of those systems that had the dynamic groups and all that kind of stuff, the first thing I would do is add a new account into Active Directory and add my account to domain admins or some other powerful group that I needed. So the problem is logging onto a system with elevated credentials that an attacker has control of. There are ways to reduce the window of time, but you can't close it completely if the attacker has control of a system that a privileged user logs onto. Question back there. Thank you for that question. It's a good one.
Hello, one question. Are there open source tools so that it's possible to analyze how tools like WCE work?
Is it possible to do what?
If there are, in the area of open source code, some tools like WCE, so that it's possible to analyze how these hashing the path tools work internally.
Okay, yeah, there are open source tools out there that do exactly that, so I'm not going to point you to any of them or name any of them. You can go to Marcus's and Hassan's session. I'm sure they would be more than willing to tell you where to go to find these things, but you see the logo here, and I like remaining employed, at least for the time being. So
only for research. Thank you.
You can Bing it. Any more questions? Yeah, lots more questions. Let's keep going.
Just one question. In order to prevent an attacker from gaining access to the machine, not using local admin rights would be the way, right?
That will help. I'm going to get to the mitigations and the recommendations. I will get to that. Having users not run as admin does help somewhat. Question?
Now, is there a way to attach an approval process to account creation?
Attach approval process. I think if you're domain admin, you've got the approval.
Even with that?
Even with that?
For an account to be created, for an approval process to be attached, and if anybody is trying to bypass that approval process, by any means, the account will be deleted automatically.
I think that comes back to admin has control, right? So there's no, like I said, there's no security boundary between local admin and the local operating system. There's no way to prevent an admin from doing anything on that box. And similarly, I don't think there's any way to prevent a domain admin from doing anything in Active Directory.
But isn't now we're like mitigating the admin power? He can do whatever he wants to do on the machine, but yet we can also inject approval points for things that we consider a high risk.
I think I'm just going to speculate, but the way I would think about it is you could add some code that hooks into Active Directory. I'm not an expert in how you modify the logic of Active Directory, but let's say you could hook that in, right? The domain admin or the attacker running as domain admin can bypass anything they need to bypass. They own the operating system. There's no security boundary that limits what they can do. They can bypass that system. In the same way that the driver signing requirement, right? That you can only, the old on 32-bit, you had to go through this dialogue if you wanted to install a driver that doesn't have a signature, right? But you could bypass, the admin could bypass that just by putting the bits directly into HKey local machine system, current control set services, just create something there, reboot, and anything they want comes in without a dialogue. Question here.
In case I deny logon from some machines in my domain, will it help for domain administrator?
I think this would be a good time to move on to the mitigations, the recommended mitigations. So, one thing I don't think I mentioned is we have a white paper all about pass the hash. The link to it is in the deck, but it has it's a very robust white paper. We just updated it actually just a couple weeks ago, and it offers it offers 3 primary mitigations. First of all, just to come back to this, the core issue here is it's not a bug in the design of Windows. It is just the problem of an operating system with a super user account that has absolute control over it. Same is true of Linux, OS2, all the Unixes. You could go to something like SE Linux. I've done a little bit of reading on that. It's not a general purpose operating system, and it has mandatory controls, mandatory access controls, so that there is no super user account. So if you can trust the installation of the operating system, it can apply rules that no user account can override. But you still have to trust the correctness of the installation, the correctness of the implementation of the operating system. But for general purpose operating systems where you have administrative or root accounts, there's no way to block an attacker who gains that from doing anything they want. I'm going to skip this. So the credentials we're talking about. Oh, there's another tool I meant to show you. Let me go back to that real quick. So another thing that attackers can do, show this slide one more time, the Security Accounts Manager database. This is where local accounts, information about local accounts are stored, including the hashes of the passwords of the local accounts. They have to be stored somewhere, and they're stored here in the SAM database. And of course, even though there are no supported APIs that will give you that information, there are tools that go in, read that information out of the registry, HKey local machine, or HKey local machine SAM, and go in and read those out. Now, in this system, there's no landman hashes, no LM hashes, but there are NTLM hashes. And so if the attacker came in and gained admin because the user's running as admin, the user is running on Windows XP and everybody runs as admin, or running on Windows 7 and they turned off user account control because it gets in the way, and they just gain admin control, they can go into the local account database and pull out accounts that if it's the same username and password on another machine, these local accounts can now be used, and the hashes can now be used to authenticate to these other machines that have the same accounts defined. Okay, and you can see here accounts that I haven't even used, it's showing you the hashes for them because they're located right there in the Security Accounts Manager database. So, like it says here, that will have the NT hash. It may have the LM hash unless that has been disabled, which it is now in the newer versions of Windows. LSASS is where all the really good stuff is. You got the plain text passwords reversibly encrypted in order to support digest authentication. You've got the NT hash. It will generate the LM hash. When you enter the password, it'll do an LM hash of that in case it needs to communicate with a system that uses LANMAN and not NTLM. And also, any TGTs are going to be managed there as well. So Kerberos credentials or Kerberos tickets can now be stolen from there as well. In Active Directory, again, similarly to the Security Accounts Manager database, you have the NT hash there. But if they can get into the Active Directory database, you're done anyway, right? I mean, they've already gained domain admin if they can get to that. Credman, this is where users store their own passwords. So they log on to a website and they say, yes, I want to save this password. It's going to store it in per user storage using the Data Protection API, DPAPI. If the user is logged in, the information is there that can extract out their passwords. That's per user information. And that's not necessarily Windows accounts. That could be other things as well. And then LSA secrets in the registry. So you want to configure a service or a scheduled task to run as under a particular user account. The operating system is going to need the username and the password of that account so that when it starts up and wants to run that thing, it has that information there. So if that is stored, that's something that the attacker can gain control of. And finally, one thing here, cached credentials. People like to call them cached credentials. They're not really cached credentials. So, you log on to a system, you don't have access to the domain controller, you're logging on with the domain account that you've used before. It will still recognize, oh yes, I know who you are, and allow you to run locally, okay, using the cached password verifiers. So these are stored on the system, but they're not really useful for anything. Okay, they're not really useful. Well, they're useful for logging on. They're useful for what they're designed for. They're not useful for extending an attack because they're not the password hash. It's a hash of a bunch of other stuff. They munge it up really badly. The only reason it's there is so that when you log on, you enter the password, it can apply the same algorithms and compare it to the value it has and say, yes, you're the one who logged on earlier. I'm going to reconstitute your user account. And here's your groups and everything, so you can run locally. Now that you've entered the password, though, that will be in LSASS, and you can authenticate to remote machines once you have connected to a domain controller. Any questions about any of this? Questions? He's running. Well, he was running. Now he's running. He's sort of jogging.
You mentioned now cache credentials, like if it doesn't matter, but isn't there a difference if you turn on cache credentials, then even when you log off, there is a possibility for this offline attack on...
Well, no, again, the cache credentials are the misnomer cache credentials. Yeah. You can turn that off, which means that when you log on to the system and you don't have access to a domain controller, you can't log on. Okay? Yeah. But the presence of that information does not give the attacker anything of value.
But when
if you can use it to brute force to figure out what the password is.
Yeah, that's
okay.
But
okay. You can do that against other sources as well. And brute forcing the cache credential verifiers, or the logon cache password verifiers, is time consuming, right? It can be used, but it's really rare that. Would you agree that's yeah? If the password is bad, if it's a weak password, then this can give it up, right? But there's lots of other ways to break weak passwords. So the cache password verifiers are having those on a system does not really represent a vulnerability or an increased threat of compromise on a system. Okay, so hopefully you're really depressed. And now we can make things a little bit better. Because there are some things you can do that minimize the likelihood that you're going to get owned through this kind of attack. Number one, restrict and protect high-privileged domain accounts. That's the number one thing. If you're on an end user's workstation, if you're on the receptionist's workstation, right, there should not be any domain admin credentials on that machine. No domain admin should ever log on to that machine to maintain it or install, patches or, any software, anything like that. Don't use those high-privileged accounts for ordinary workstation maintenance. If the domain admin password is not on that machine, then the attacker who gains full admin control of that machine has nothing to steal. Okay? We'll go over some details about that. Second, protect yourself against lateral attack using the local accounts. There are ways to limit what you can do with local accounts. And I think what we're going to move, I'm speculating about where Windows is going to go, but the idea has already started taking shape in Vista and above, or Vista and newer, that local accounts should only be used for logging on locally at the console or maybe remote desktop, not over the network. You enforce that, and then the lateral movement can be broken, at least for abusing of the local accounts. We'll go over some of that. And finally, using the Windows firewall to protect against the lateral movement, because do workstations really need to talk directly to other workstations? Do you really need that peer-to-peer kind of communication? Should it be there wide open, right? Should you be able to authenticate to remote machines using your Windows credentials? Question.
Yes, about the first mitigation. What about privileged account logging from workstations via RDP to servers to do some stuff?
Using RDP?
Yes.
Yeah, I'll go over that. There's different logon types, and some logon types put the credentials on that remote machine so that they can be abused and used elsewhere. Some types of remote authentication don't. And we'll go over the differences. But first, using high privileged accounts. The highest privileged accounts should only be used to manage Active Directory itself. Domain admin accounts should not be used to manage SQL Server machines or Exchange or end-user workstations. Only ever use them to configure Active Directory and to maintain Active Directory. Admins, people with admin accounts, should have a separate account, completely separate user account for their administrative activities and their day-to-day stuff. Okay? They should not be logging on to, they should not be browsing the web using domain admin accounts. They should not be logging on to email using their domain admin accounts. They should have a separate account for that. Use separate workstations to protect the domain admin accounts. Don't have the domain admin account. I mean, you can have a single user who has both types of accounts, a standard user account for his email and a separate admin account for managing Active Directory. You don't want to use both of them on the same computer, because if the standard user one gets owned, now running as standard user, that shouldn't cause the machine to be owned with admin rights. The attacker should not be able to get admin rights, but once they run code on the machine, they may be able to find an elevation of privilege vulnerability and gain admin rights that way, right? Perhaps a bug in the server service or third-party antivirus, and gain full admin control that way. So just don't use those accounts on the same machine. Use a dedicated workstation that is specifically for domain administration. Mark privileged accounts as sensitive and cannot be delegated. So if you enable delegation, then systems, you can log onto one system, connect to another. That system with delegation can then use that account to authenticate to yet other machines. Ordinarily, that's turned off, and with NTLM, you were never able to do that. So make sure that delegation is disabled for these high privileged accounts. And do not configure services or scheduled tasks to run using high privileged accounts on lower trust computers. So if your backup software insists we need an agent running on the end user workstation and it needs domain admin privileges, you need to say, please update your software to fix that problem, or we have to go with someone else. Don't have services running on those machines, because you saw that the domain admin password has to be on the system in order for the software to run. And that will make it vulnerable. So you don't want to do that. Okay, so if the credentials are never there, if the high privileged credentials are never on the machine, they can't be stolen from the machine. So that's the number one thing. Number two, protecting local accounts. We want to prevent the lateral traversal. So Windows Vista and newer, with user account control. You know that when you log on, I'm sure, how many of you have gotten off of XP and have run Vista or Windows 7 or Windows 8? A few of you? Come on. How many of you are still running XP and have never run Windows 7? One. Okay. It can't be 0%. It's never 0%. How many of you are still running NT4? Good. Okay. So when you log onto a system and you're an admin, right? Everything runs as standard user until you say this needs to run as admin. You get the elevation prompt, right? And then you click yes, and now it's running as you with full admin. The way that works is when you log on, it does this thing called token filtering. It creates two separate LSA sessions. I don't know if you noticed that there were two interactive sessions for Abby on the machine. One of them was an LSA session representing the user running with full admin rights, the other standard user rights. And so what it does is it uses the token from the standard user logon to run Explorer and everything else until I say, please run this with admin rights. Then it uses the token from the other account. So when you use a local account to authenticate using a network logon like netuse, what will happen is the remote system, if it's Windows Vista or newer, will use the lower version of that, the filtered account, the non-admin account, which denies it access to $, admin $, etc. Okay? The effect of this is that local accounts can no longer be used for remote administration. And that's a good thing. Okay? The reason wasn't actually, well, I won't go into the reason. They had their reasons for doing it. It has the beneficial effect. The one exception, though, is the built-in administrator account, the -500 account. By default, if that account is enabled, does not have token filtering applied. I don't know if you've ever logged onto a Windows 7 system using the administrator account or whatever it is in your local language, but everything runs with full admin rights. And so when you use that across the network, by default, it does not have filtering enabled. So it will run with full admin. So you want to go into local security policy and say, apply the filtering to the built-in administrator account as well. The other thing to watch out for is there is a registry value, and if you look this up, local account token filter policy. Local account token filter policy, all one word. If you look that up, Bing it, not Google, Bing it, you will find a bunch of references on the web saying you want to create this registry value and set it to 1. And then token filtering is turned off for those local accounts going over the network, and then everything works, including past the hash. So we're starting to develop our guidance, modify our guidance, or update our guidance to say, make sure local account token filter policy is set in the registry and that it's set to 0. To say token filtering does take place. Because then local accounts will not be able to be used for administrative lateral traversal. Another thing you can do, second bullet under the how, is deny those accounts, deny the local accounts the ability to log on over the network. You may want to do it both for network logon as well as for remote desktop. Okay? Just use local accounts at the console. That's the only place you should ever really need to use them. But you can set this in local policy, go through and make sure all the local accounts are set to deny logon over the network. Another thing you can do is to make sure that these accounts don't have the same username and password on every machine in the environment, because that will also break the ability to use these local accounts to go from machine to machine. Unfortunately, Microsoft does not have a solution today that will do that for you. In fact, we have a group policy preference that sets it the same everywhere in the environment. Yay, Microsoft. But there are third-party tools, and there are other ways you can do it just with scripts and things like that. We're actually trying to develop a tool that we can put out there to help with this. But if they don't have the same username and password on all the machines in the environment, that will also break the ability to use that for lateral traversal. Finally, restrict inbound traffic using the Windows firewall. You need to be able to define what machines in your environment are allowed to connect to which other machines. Okay, so you may have administrative servers or vulnerability scanners that need access. You need to allow those in. But workstation to workstation should not allow connections from peer-to-peer, with some exceptions, because there is some peer-to-peer software. For example, Link, Microsoft Link, the instant messaging, starts out with a server connection, but then for performance reasons will actually establish peer-to-peer communications. And you can enable that without risk of elevation of privilege, or lateral traversal rather, because it's not using logon in order to communicate. Not all traffic between machines uses Windows logon in order to establish communication. So you're not getting user A communicating to user B. User A's credentials never come across the wire. It just uses a certificate to prove server says I am Marcus Murray, and then the other side just trusts that certificate, and there's no actual Windows logon, and so no possibility for elevation of privilege. Some other things. So those are the three mitigations, and the reason we put them in the paper is anybody can do this. You can do that fairly easily. There's some more advanced stuff you can do. We wanted to make the white paper stuff that customers across the board can implement relatively easily. Some additional recommendations we put in there. Question came up about not having people run with administrative rights. Now, this doesn't affect pass the hash. Now, remember, in the original graphic that showed how the attack takes place, nothing happens until some other unrelated vulnerability gets exploited and the attacker gains admin control of a computer. Then they can start doing the pass the hash attack. But they need to get into the environment first with admin rights. So if your end users are running a standard user, that greatly limits the likelihood of an attack coming in and gaining admin rights, because they're typically coming in through the email client, the web browser, through Java or Flash or something like that, and the attack code is going to be running as standard user. It's not going to be able to open LSAS and get to the secrets that are in there. Once they're on the machine, they may be able to execute an elevation of privilege exploit and gain admin, but that's additional work. It gives more opportunity for the attacker to stumble and fail, gives more time for the system to detect that something is going on and to protect itself. So not having users running as admin goes a fairly long way to preventing the initial landing point from which pass the hash is going to take place. Number two, limit the number and use of privileged domain accounts. Don't have 100 domain admins for an environment with 1,000 machines, right? That's just way too many. The more you limit it, the less likely something goes wrong. Privileged accounts. limiting what can be done with privileged accounts. Set the proxies to deny internet access to those accounts so that domain admin doesn't browse the web and hit some vulnerability external to the environment. And similarly, make sure that these administrative accounts do not have email accounts, so they don't run email and increase the risk of compromise that way. This goes to the question earlier. Use remote management tools that do not place reusable credentials on a remote computer's memory. So I showed you earlier with logon sessions that there are different types of logons. There's interactive logon. Basically, it all comes down to the logon user Win32 API or the LSA logon user, where you specify this is the logon type I want to use. Network, interactive, remote interactive, etc. Some of them end up putting the secrets in the computer's memory and others don't. And I'll actually demo this. Okay, so this is my workstation. And I need to manage it. And I want to manage it not using domain account. I've created a workstation admin account. And I'm going to run it from this other machine. So running as workstation admin, I have an MSC file that brings up computer management specifically to manage this other workstation. Okay, I am now using this MMC snap-in to manage the remote machine. I can go into the event viewer and see the Windows logs and things like that. Have I put the workstation admin's credentials onto the remote machine where they can be abused? Let's go have a look. You can see workstation admin is here, but the logon type in all cases is network. Okay, so it's using a network logon using NTLM. That does not put reusable credentials into memory. Let's run WCE. And we can see here it does have the administrator's hash in here because I took it earlier. The admin is not logged on, but the hash is in memory. The local account is in here, the domain admin, the local machine, but the workstation admin account, its hash is not in memory because it's using a network logon. So this is, the limitation of NTLM is you can connect to one machine, but then there's nothing on that machine that allows it to connect to another machine running as the same account. Let's compare that, though, to an RDP. This creates a remote interactive logon, which is very, very similar to an interactive logon. The credentials have to be on the remote machine. If you're logged on using a remote desktop, you can connect to other machines from there. Why? Because your credentials are in LSASS on that machine. I haven't figured out why this takes so long on this in this demo environment, but we'll see here in just a moment that it will connect, it will authenticate, I really should debug this and figure out why it takes so long, but it does work. So this would be a great place to tell a joke, but there, okay. Now, this is the remote desktop client. There's another user logged on, so it needs to ask me, do I want to ask it to log off? Before I do that, workstation admin, remote interactive logon. Even though I don't even have the desktop up yet, the logon has taken place, 2 of them because it's running as admin, so it'll have the user account control filtering, so there's 2 sessions. And WCE, that hasn't happened. That did not happen when I tested this earlier. kill this other WCE, see if that helps at all. Okay, there. Ah, it disappeared on me. The other one timed out. This will take too long if I do it again. But you will see, you'll have to take my word for it unless we want to stick around and watch this go through again. You will see the hash in memory because it is putting the credentials into memory. It's sending the password across and creating the local logon. Come back to that in a second when this comes up. So yeah, remote management tools, and the white paper lists all the, here, it's back. So we've got that screen there, and we do WCE, and there is workstation admin's credentials in memory, even though the desktop never even came up. So RDP is one that you don't want to use because that will expose the privileged accounts credentials. Network logon isn't. And in the white paper, we list the different types of tools, including PSExec without credentials, PSExec with credentials, remote desktop, MMC snap-ins, which ones put credentials on the remote machine, which ones don't, PowerShell remoting, etc. Avoid logons to potentially compromise computers. Don't use the domain admin account to log on to a machine that you think might have a problem. Use a local account. Disconnect it from the network. Going back to the using non-admin accounts. Also, update applications and operating systems. The attackers will use exploits of vulnerabilities, vulnerable versions of Adobe Reader, Flash, Java, Excel, Word, etc., the operating system itself, browsers. Make sure you're keeping them up to date religiously. If you has anybody been to the Hacker Tools demo that Marcus and Hassan did? So you saw oh, how many of you went to it in New Orleans then? How many of you will go tomorrow? It's a pretty exciting show, and they'll show you, not to steal any thunder here, but there's some tools out there that come prepackaged, ready to use entire libraries of vulnerabilities, and they get updated all the time. So when a new Java vulnerability is discovered, which happens with fairly incredible regularity, those libraries will be updated so that you can now just, with a few clicks and a few commands, build exploit code that will attack someone else's computer if they have that vulnerable version of Java. So keep your stuff up to date. And that helps limit the likelihood that someone comes in and gains control and gains a foothold on one of your machines. Secure and manage your domain controllers and remove LM hashes. So by default, landman hashes are disabled, so they're not going to be in the Active Directory database or in the SAM database. The problem with the LM hashes is they use much weaker algorithms. It's much easier to take an LM hash and figure out, and crack it apart and figure out what the original password was. And if you have the password, you don't need hashes, right? So the landman algorithm was probably really, really good 25 years ago. It doesn't stand up anymore. So disable that so that those hashes are no longer in the local account databases or in Active Directory. So some other mitigations that people think, that the various recommendations come out and say, this will protect you. Do this and pass the hash disappears. First of all, remember, the pass the hash is just one example of credential theft. If you can get the password, like I just said, you don't need the hash. If you can grab a token from an existing process that's running as domain admin, that gives you access to everything that the domain has access to. And the thing about taking a token is you can do the whole thing using documented and supported APIs. Open process token, impersonate. Now, it requires admin to take over a process running under another user account, but if you've got this on a compromised machine, that kind of thing can happen. So, disable NTLM. What we're finding is this isn't really practical yet. Okay, there are places where it's still needed. Smart cards. Like I said earlier, when you log on using a smart card, at some point you're going to have some information on the system where the system can just grab something and use a protocol, just using software, to go across the network and authenticate as you. On the remote machine, there may be some evidence that it came from a smart card, but it's not necessarily as reliable as having a physical device. Right? So it does get converted to bits on the wire at some point. And so smart card, while it does protect against password theft, does not necessarily protect against pass the hash. Jump servers. People recommend jump servers. Jump server is basically you've got two networks that are segmented from each other and one common point, one server that's connected to both. And the typical use is you'll do a remote desktop to the jump server, and from that desktop run a remote desktop shell to another machine inside that second environment. Does that protect against pass the hash? Not really, because again, anything that the software can do, your attacker can do as well. Once you establish that connection, you're entering credentials, you're typing them on the local machine for one thing. So the credentials can be stolen by anything with a keylogger, well, maybe not a screen scraper, but a keylogger. And there's lots of ways to do keylogging even without admin rights. But those credentials can be stolen and then reused to compromise the jump server and go from there. And rebooting workstations and servers. So you see the stuff you saw in here earlier that I actually had some leaked sessions. Like this Abby session here is from a logon that disappeared. Now, those aren't supposed to be there, but there are. What will happen is if a logon, and there's a token associated with the logon session, if some process still has a handle open to a token connected to a logon session, the session remains alive. The hashes remain in memory. And while we've tried to close out all the bugs that cause that to happen in Windows, third-party tools may interfere with that and may keep handles to tokens open longer than you'd like. If you reboot, you're guaranteed to flush out everything in LSAS's memory. Does that protect you against pass the hash? Only that much. Because if the attacker has control and you've logged on, it's already too late. And rebooting does not necessarily get rid of the malware. The first thing malware usually does is find a way to persist so that when you reboot the machine, it comes back up too. Maybe with a rootkit, maybe just with a service that is well hidden. So, wrong screen up there. Rebooting workstations and servers. So is the problem solved? Clearly no. These are initial steps. We're continuing to do work to try to figure out additional ways to help limit the scope of the problem. But like I said, there's a core part of the problem, which is a compromised machine, compromised with admin rights. There is a vulnerability to you if high privileged accounts are used to log on to that machine. But we're working on additional stuff to help limit the scope and make it easier to protect against these kinds of attacks. So the white paper, Mitigating Pass the Hash Attacks and Other Credential Theft Techniques, is up on the web. You can just Bing for any part of that phrase, and it should come up fairly quickly in the results. Spread the word. And if you're interested in advanced architectures, mark.simos@microsoft.com, contact him. He has something, and actually I'm going to go through it for just a moment here to show some of the kinds of thinking that they've been working on. They're harder to implement, but if you have something of value that you want to protect, it may be worth it to go to that expense to try to implement some of this stuff. So Mark Simos is one of the people who came up with the Enhanced Security Admin Environment, which the cybersecurity services team at Microsoft has deployed in a number of customer environments. So first of all, what we do is segment the different parts, figure out where's the stuff of greatest value. Clearly the domain controllers are of highest value, but the machines where the data are is also of tremendous value. In fact, your company can be, can die completely without the attacker gaining access to the domain controller if they just know that you're going to make a bid at a particular price, and they come in at a few cents lower. You can be out of business in a year, right? And there are attacks that have done that successfully. So you need to protect where the data is as well. And so credential partitioning is the first part of this, where strict enforcement is done to make sure that only domain admins log on to domain controllers, and domain admins do not log in anyplace else. Server admins log on to the servers, maybe from dedicated workstations, but not from the lower value end user workstations. Furthermore, they created a separate forest that actually contains the domain admin account. So it's a separate forest, and using selective authentication from the admin environment is the only place where the domain admins log in. Okay, so the domain admins are all in this separate forest over here. So it's not possible to log in as domain controller from down here. Furthermore, these domain admins who use smart cards are actually only standard users in the admin environment. So they cannot corrupt the admin environment. And the actual domain admins for the admin environment are offline. So there's a lot of stuff that can be done here to protect an environment from having these systems compromised to that level. And that's just a taste of what they've done. But yeah, this takes a lot more work. It's probably a bit more of a pain to live with, but if you don't want to have your domain attacked, this kind of thing can help. It may be worth the cost. And so contact Mark if you're interested in learning more about that. Related content, a lot of great sessions here about hacker tools, advanced persistent threats, be it Ask the Experts later, and additional resources, the standard slide deck. Evaluate this session. Please evaluate the session. My recommendation about the evals is if you liked the content and liked the presentation, please fill out an eval. If you didn't, please just come talk to me. No need to fill out an eval. I'll take care of it myself. Okay, any last questions before we shut it down? Was this valuable? Did you learn something? It was just a thumbs up. Okay, not a hands up. Okay. Well, thank you very much for coming. It was a pleasure to be here to talk to you. Thanks a lot.